Alrighty, welcome to the 2020 Mathematical Methods External. In this video, we're doing the multiple choice for the Tech Active paper, which is paper 2. Let's dive straight on in. Keep in mind in this video, I'm going to be using the TI-Nspire CX II calculator. A lot of the things I do though will be transferable to the calculator that you use if you don't use it. However, it would be best for this video if you do have the TI-Nspire calculator. Okay, question 1. We have the limit of some function as h approaches 0. And I first just want to indicate that you can't just sub in 0 here because you end up getting 12 to the power of 0 is 1. 1 minus 1 is 0 divided by 0. And all of that's undefined. So that's no good to sub in 0. What we have to do is sub in smaller and smaller values and see what the answer approaches. So in terms of using the calculator for that, I'm going to go ahead here. I've just got a calculator open. And I'm going to type in define f of h, because our function is in terms of h, control divide, and we've got 12 to the power of h minus 1 all over h. And now that's defined. The point being, here in this f of h bit, I can just sub in values now. So for example, f of 1, that's 11. Okay, let's get small, let's get closer to 0. F of a half, okay, that's 5. F of 0.1, 2.8. Let's go really small. 0001, 2.5. Let's go really, really small here. Heaps of zeros and hit a 1. Okay, that's too small. That's too small. Let's just go a bit smaller. Here we go. It looks like it's approaching 2.5. So now back in my answers, C is 2.5. So it seems like a no-brainer to me. As X or H in this case gets really small, F of H approaches 2.5. Alrighty, question 2. Now in question 2, we have some formula here. I'm going to highlight it. The pH based on H+. H+ is the concentration of hydrogen ions. And we get given that the pH is equal to 0.2, which is this value in the equation. So I'm actually going to get a new equation. I'm actually going to get 0.2 equals negative log base 10 of, and instead of H+, I'm just going to write X for the variable. And I am indeed the concentration of hydrogen ions, which is that pink highlighted section, which is just my X value, right? So I'm basically just solving this equation for X. Don't worry about log laws, don't do anything by hand. Straight to the calculator. We're gonna type in here nsolve of 0.2 is equal to negative log base 10 of X, and we are comma solving for X. Hit enter, 0.63. Yes, part B, selection B, option B is the answer. Sweet, use it all in the calculator. Question 3. So let R, sum R, be the region enclosed by this graph here, the x-axis and the lines x equals 1 and x equals negative 1. So what's the area of R? So I'm just going to use the graphing functionality on the calculator here. So menu page, to get a graphing application going. And I'm just going to type the function in, x times e to the x. We want also some relations here. You can't just type in, by the way, x equals 1 because it's not a function of x. So what you have to do is click menu, graph entry edit, and then select relation. Then you can type in x equals negative 1. You can press tab to go back to the most recent entry, x equals 1 as well. And I also want y equals 0 because that's the x-axis. Now I want to zoom in on this section here, so I'll go menu, Windows zoom. You can just type in the exact settings you want, but I'm just going to click this zoom in button, zoom in on the center, and one more zoom should do it. Oh, I might zoom out one. Windows zoom, zoom out, and we'll zoom out a little bit so I can see the top area here. It's not going to really matter. Now, what I do want to point out is if I just do one big long integral, it's gonna, because this is a negative signed area, it's gonna actually do the difference between the areas, which is not good. I want to add them together. So I'm gonna do 2 separate integrals here. So menu, analyze the graph, and we're gonna go integral. And we're gonna go, first of all, select the graph. It's this graph. And I wanna go from negative 1 all the way to 0. And you can see that's the area there, 0.264. It's negative because it's below the x-axis, but it's still 0.264 of an area. And if I do it again, analyze graph, integral, and then same graph, but from 0 to 1 this time, I'm going to get the area of, oh, 1, exactly 1. That's pretty cool. So combined, they are 1.264 in terms of area, which looks to be B. So I'm going to select option B for my total area. Okay, so question 4 says, consider this log function. It tells us P is bigger than 1, so it's just like a regular shaped log function. That base is greater than 1. But Q is between 0 and 1, not including 0 or 1. Now, because that Q value, this here, is just this little bit, and it's plussing Q, it's adding Q onto X, that's going to shift my function to the left, not actually to the right. So that means that my function that normally, right, your normal log function, oops, that's not what it looks like at all. This is what it looks like. This point here, that's not what it looks like either. My goodness, I should have drawn the axes first. Here we go. That point there, this log function, right? This point here is what I'm trying to get at. This is the point 1, 0, right? It goes through X equals 1. But if our Q value is between 0 and 1, it means it's going to be shifting it to the left by anywhere between 0 and 1. So it's going to be anywhere between, that intersection point is going to be anywhere between the origin and X equals 1. So if I just put that real quick on all of these graphs, this is the point 1, 0, my function should be going left. So first things first, A is not an option because it goes too far to the left. So notice it's only less than, it's not less than or equal to, so it can't shift the full, or rather this part, it can't shift the full 1 unit. So we can rule out that because it goes through the origin. The second one goes the wrong direction, it's going to the right. So the last two are my only options, but this one, D, goes too far. It goes more than 1 unit, so it must be here, this answer of C. It goes between 0 and 1 units to the left. Alrighty. Question 4 done. Let's move on to number 5. We've got an object moving a straight line with a velocity function given by that. It says the object is at the origin initially. It says, what is the displacement time graph? So if I'm going from velocity to displacement, I am integrating, I'm not deriving. So what that means is that this velocity function here, this v of t, that function is the first derivative of one of these graphs. So what I'm actually going to do is I'm going to sketch on my calculator that velocity function and then use my understanding of the relationship between the first derivative and the original primitive function in order to figure out which is the displacement time graph. So I'm going to go here, I'm going to add another graph just because that last one was really cluttered. And I'm going to add in here the function, 40 bracket e to the negative t, but in this case, because it's on the Cartesian plane, it's going to be e to the negative x. Okay, but we can understand that that's the same thing as e to the negative t, and this one's going to be e to the negative 2x. And we're going to graph that. Okie dokie. Just play around with the window on your calculator. I'm just going to go quadrant 1. That might help. Okay, that gives me a better understanding. All of this seems superfluous, all this extra space on the right. So what I'm going to do is I'm going to go window zoom, window settings, and just change that x-axis. Maybe I'll make the max like 8 or something. And that looks a little bit better there. So I can kind of see what's happening. Now, what I want to do is recognize that this is the derivative. So this function tells me about the gradient of the original function, the primitive function. So when this function goes to the left, so negative t values, which of course can't really happen, but it helps us understand the graph, those values are negative, which indicates to me that the gradient to the left of the origin of the original function should have a negative gradient. So we come back to the exam, having a look at this, understanding that everywhere to the left, which I'm just going to highlight in green, everywhere to the left in each of these functions should have a negative gradient the entire time. So this should be helping us to remove some of these as options. So this one, C, has a negative gradient, so that's okay. D appears to have a negative gradient, that's okay. B does as well. Notice that A, though, in that green region, has a positive gradient. We can rule out A as an option. Okay, back to the calculator, let's analyze a bit more. Now I'm at the calculator, I can see that, let's actually find this, one more thing is to the right of the origin, all values are positive, which means that function is always increasing, right? This tells us that the gradient of the original, the ones that on the exam, because this is positive, all of those tangents are going to be positive tangents, positive gradients. So back to the exam, you'll notice that this one here, this is still negative to the right of the origin. That's no good, it doesn't count. This one as well, they're still negative, doesn't count. Whereas C has positive gradients. It is decreasing, right, in terms of that gradient, but it's always positive. So C must be my answer. Process of elimination just like that. So C, my answer is C. Moving on to question 6, and you'll notice, back to question 5, you will notice that I didn't have to actually integrate that thing. I didn't have to waste time doing that. Yes, it took me a little while, but it's kind of because I was explaining it and bouncing back and forth between the calculator and the exam. But I didn't really have to do any maths. I just had to have an understanding of the first derivative and the primitive function. So keep that in mind. We're choosing C, question 6. Okay, so we've got oil leaking from a tanker at a rate of some function of T per hour, where T is in hours. Determine how much oil leaks from the tanker to the nearest liter from 0 to 10. First thing to note is that it says here it's a rate. So R of T is actually a derivative function, meaning if we want to get from a derivative, I'll just annotate this here, this is a derivative, or something like f dash of T, we want to get back to f of t, right? Which is going to be the integral of f dash t. And we want between 0 and 10 hours. 10 hours? Is it hours, minutes? Hours. Okay, so 0 to 10 hours dt. And I'm going to purely set that up in the calculator, not do any integration by hand. So let's go ahead and do that. Over here on the calculator, you've got two choices. You can go menu and go to calculus menu. So menu, we've got to go back to, so control left to navigate through these here. And we can go to the calculus menu and find the integral, right? But I prefer to use this templates menu here. Click that, and then you're going to be looking for this one here, the integral between 2 points. We've got 0 all the way up to 10, and we've got 9,000 times e to the power of negative 0.2 x dx, and the answer is 38,909.9, which is more or less 38,910 liters. Question 6 done with a simple function on the calculator. Question 7. The records of a shoe manufacturer show that 10% of shoes are made defective. So straight away, that indicates to me that P equals 0.1. Assuming independence, the probability of getting 2 defective shoes in a batch of 20. So this assuming independence bit indicates to me that it's like a binomial distribution. P is 0.1. So you've got two choices. You can either recognize that that's going to be 20. So this is the probability of getting exactly 2 is going to be 20C2 times 0.1 to the 2 times 0.9 to the 18. And you can put that in your calculator, which I'll demonstrate now. So we've got, in this functionality, we've got NCR 22 times 0.1 to the power of 2 times 0.9 to the power of 18, and hit enter, and you get 0.285, which is one of my answers. That's B. But probably a faster way to do it on your calculator is if I go menu, statistics, and I want a distribution here, it's going to specifically be a binomial PDF, not a CDF, because we're not looking for a range of values. It's just 1 point. So we're going to go PDF. The number of trials was 20. The probability of success was 0.1. And the X value, aka how many successful trials, was 2. We hit OK. Gives us the exact same answer, but that might be a little bit faster in terms of typing it out, or you just might prefer that functionality. But whatever way you slice it, the answer is 0.285, which is B. Moving on to question 8. Okay, we have a non-right angled triangle. We are looking for the size of an angle A, so I'm going to label that as theta here, and we basically just have to reverse the cosine rule. Now the cosine rule on your formula sheets, I'm pretty sure is represented like this, b squared minus 2ab cos c. So rather than trying to rearrange the equation, I just tell my students, you're probably better off just scribbling out the wrong variable in the diagram. As long as you know like you're finding the right angle, scribble out the wrong variable, and then you can just write it how it's set up in the formula. So then we can just substitute in and solve. Two options, you can rearrange this equation by hand, and you'll get c equals inverse cos of a squared plus b squared take c squared over 2ab. Like, you can kind of remember those formulas and input them, or you can type it into your calculator and solve for that variable. So I'm going to try that one. I'm going to do n solve. We've got 8.8 squared, that's c, so c squared that is, equals a squared, which is going to be 11.3 squared, plus b squared, which is going to be 9.9 squared, minus 2 times a, which is 11.3, times b, which is 9.9, times cos, trig functionality here, and we'll choose cos, and we're looking for whatever, I'm just going to call it x, and we're solving this equation for x. Now, quickly, I noticed that the answers are in degrees, so at the top before I hit enter, I'm just going to change it to degrees, and now I should be ready to just go ahead and hit enter. And I get 48.5 degrees, which is A, so I'm just going to select A. Alternatively though, of course, you can just substitute all the values into this rearranged expression and just type it into your calculator. Either way, hopefully you get 48.5. I just think it's a bit faster to use nsolve so you don't have to do any algebra. Okay, and question 9. 2 to go. We've got the displacement of a particle is represented by some function. We want the acceleration. So if I'm going from displacement to acceleration, I'm deriving twice. At a specific point, this is a derivative at a point. So in your calculators, you cannot just do the derivative of a function and get the answer. Like in terms of algebra, it's not allowed to do that. Even this one, even my calculator that has algebra functionality, in test mode, you can't do it. What you can do is evaluate a derivative at a point though, and you never even knew the derivative. I'll show you that on the calculator. So my function, I'm just going to quickly define it. S of t is equal to t times ln of t, and that's minus t. So that's defined now of s of t. What you want to do, go menu, go calculus. Notice some of these are grayed out. That's because it's in test mode and I can't do that algebra. So I'm going to go derivative at a point, which I can do. And the variable I'm using is t. The value that I'm trying to evaluate is at t equals 3. And I'm actually doing this second derivative. So when I hit OK here, it's going to take me to this setup here. And all I have to do is type in now, I want s of t. And I want to derive that the second time. And I get 0.33333333, which is going to be part B. And last but not least, we have question 10. It asks for the approximate value of x where the graph of this function changes concavity. Okay, so if I'm going to be graphing something, I'm going to be going to my graph. I might add in a new graph so I don't have all those other graphs on my graph. I said graph many times in a row. Let's just type it in here. We've got x cubed plus 6x squared plus 7x minus 2 times cos of x. Now keep in mind, typically when you graph, you want to be graphing in radians. So just keep that in mind, unless otherwise indicated, graph in radians. And we want when this guy changes concavity. So all that means is I'm going to go menu, analyze this graph, and I'm looking for a point of inflection, which is turned off with my algebra. Okay, I'm going to go ahead then and just look in here and just try and find where it is approximately changing concavity. I'm looking at my answers. What have I got here? -1, -2. So it's a bit before -2, which appears to be D, -1.89. Let's just graph that. So I'll go menu, graph entry edit relation. I'm going to go x equals negative 1.89. Oops, that's 0.189. I wanted 1.89. And yes, I might just change the window so we can see it a bit better. Narrow in on these x values. Let's go -5 to 5. And that's good enough. Okay, so that looks like it is pretty much the point of inflection there at -1.89. So I'm going to select D for question 10. And there you have it. Okay, so the point of the multiple choice, right, for a tech active exam is to get the right answers. I know, crazy. I know, dropping knowledge. My point being is that you don't have to show any working. You get 1 mark whether you do all the algebra yourself or whether you do it all in the calculator. So in the tech active exam, please abuse your calculator as much as you possibly can in multiple choice. In the short response, which I'm going to be doing in a future video, which is probably on the playlist already, you do need to show your working. So obviously you do, but multiple choice is worth 1 mark and 1 mark only. So use your calculator as much as possible. Go nice and quickly and just get the answer that's correct using your knowledge of mathematics and the calculator's calculating power. So hopefully these solutions helped you out. Hopefully the calculator use helped you out as well. If it did, make sure you like the video. Appreciate it a lot. If you want to learn more about the calculator, consider subscribing and clicking on a few of the videos where I show you how to use it as well. And I guess I'll see you in the next video about my external exam solution series. See you in the next one.